And what's up, guys? So let's solve to one interval between identical elements. So this problem is not easy, I think so. I think it's not non-trivial. So you get zero indices array of an array, and basically you interval between two elements in the array defined to be absolute value between these indices. So I and j, and you need to return any intervals of length n, where interval I is the sum of intervals between array I and each element in the array with the same array I. And yeah, so this problem may be hard to understand. Maybe you just want to see one example. So right, so let's imagine that somebody give you a dictionary. Okay, so now you go to 2. So this is key, and this is the indexes that it happened, right? So for 2, it happened at index 0. For 1, it happened in index 1. For 3, index 2. For 1, right, you get the same thing 1, right? So let's say this 1 is index 3. And for this 2, which is index 4. And for this 3 is index 5 and 6. Okay, so you need to return your answer. Let's say this is your answer. So your answer need to count start from 2 again, right? You get 4 because you this one distance 4, and for 1 you get 1 and the distance 2, and then for 3, so for 3 you start from these 2, 5 and 7, right? So you need to count this minus this distance and this distance, so it's 3 plus 1, so it's oh sorry, 3 plus 4, 3 2 5 6, yeah, 3 plus 4, so it's 7. Now it's 2 again, so it's still 4. So it's sorry, it's 1 again, so 1 is still 2, and the 2 again is still 4, and the 3 again, so 3 is here, right? 3 and 3, 3 and 1, so it's 4, and for 6 you get the least, right? So for 6 you get the 1 and 4, so it's 5. Okay, yeah, so this is the answer. Okay, so I think this iterates already tell you the brute force answer. Okay, so brute force answer is that you first create this dictionary. Right, so you can just create this dictionary and do what I do. Do what I just do. Right, for each, now you go through the you go through the array twice, and then once you go through array twice, then you let's say, so right, so for fixed x, you will get all the indices happen in x. Let's say a1, a2, a3, say an, and for I iteration, let's say ai, then you just compute all the difference. Okay, then put into the array I. Okay, so for given indices, you know dx, you know what the number x is it, and then this is d of x, which is a list which happen to be all the x, and then you can compute this. Okay, so this is the brute force solution. But if you see the brute force solution, you will get the TLE. It's not bad past 56. So basically the same thing I said, right? You create this type of dictionary, and you go to answer, and then you go to the array, and for each j in indices d of x, right? For such indices, you just compute ABS, absolute value j minus I, and append g. Okay, so this is the brute force. You can solve at 56 of it. Right, so not good. But at least you know this is true. Okay. So one idea I come up with is that we hope to. So basically, you can see that every time we compute these n results, we actually we compute a lot of redundancy, right? For example, if I compute these 2, actually I already know all the answer, right? I shouldn't need to compute everything again. Okay, so the problem become the following. Now, so once you understand this problem can be solved by pure mathematics. So let's say you get a line which is a1, a2, a3, and let's say aj is what you want to compute at an. Okay, then how do you compute? And the key idea is how to compute the difference, right? So this aj, the difference between aj and aj minus 1. So what we going to compute is aj, minus AI, where I less than j, and the plus summation AI minus aj, where I greater than j. So the idea is that we need to find the simplification of this formula. And once we understand this, then we can easily to compute. Also very simple, this aj is fixed, right? So this is j minus 1 aj minus summation I minus j ai plus summation I greater than j minus aj, right? There are, let's say, n minus j. Okay, so they just separate. And obviously that these two terms can be combined. So I should get a 2j minus 1 minus n aj minus summation I minus j ai plus summation I greater than j ai. Okay, so every time you see this, you should use the so-called pre-sum. So let's define Sn. Is this Sn defined to be summation of I from 1 to n. Okay, so the first term is written as 2j minus 1 minus n, and sj minus sj minus 1. Okay, minus, so what is this? So this is just a j, this is a1, a2 up to aj minus 1. So this is just sj minus 1. And for this one, this is just plus sj. So for this one, is you start from j plus 1, you start from j plus 1 up to final results, right? So it's just Sn minus, Sn is a total sum minus Sj, okay? So these results is just 2j minus 1 minus n. Right, so you combine this minus 1 and then this minus 1, right? So you get minus 2 Sj minus 2j minus n Sj minus 1, because there's Sj minus here, plus Sn, okay? Let me just change this. Okay, so this is Sj and the Sj minus 1 and the Sn. Okay, so this is called, this is just the pre-sum. So once you compute the pre-sum of this Sn, then you can just, for each indices, you just put this in, right? So I should possible down to On for the general case, for the average case. So originally it should be n squared, n is the length of the array. Okay, so yeah, this is the answer. Okay, so how do we compute a pre-sum? Right, compute a pre-sum is very trivial, right? You can just do a trick. So let's say this D is a pre-sum, and right, for I in X enumerates, if X is 9D, which is that number is 9D, I initialize a pre-sum. So usually in the pre-sum that we will put 0 here, and then we just append the dx minus 1 plus 1. Right? So this now D is a pre-sum, and I use indices dictionary to remember a dictionary. Sorry, right? So D is a pre-sum. Okay, then now yeah, and now we go through this D keys. And now we go through these D keys, and let's say n is the length of X, right? So the trick is that we need to know what this n is, right? Because we need to, there's n here, right? So let's compute n is length of D, and for I in the range n, and the j equals I plus 1. Now this is very easy. I just, because I start from my formula derivation start from 1, right? So I just for convenience I define j to be I plus 1, and for that answer, so we initialize all the answer to be 0, 0, and then for that answer index xi, so this is that j terms equals to dxj, right? So this xj is just dxj, right? Because this d of x now is a pre-sum of x, right? So dxj 2j minus n minus 2 minus 2j minus n dxj minus 1, which is exactly the formula that I derived, and plus dj x minus 1. X minus 1 means that Sn. Okay, so this is the you see in this case you enumerate all the keys and all the n. So total you should only have you should be On, right? Because in this case On, and this type you only compute n times. Okay, so this is possible that you can solve this problem, not so difficult, but still can solve it. Okay, see you guys next videos.